Hey everybody, so we are going to be talking about the story behind why the multiplication and division rules for integers work the way they do. You might already know some of these rules and maybe you don't. Either way, it's fine, but today we're talking about why they work. So we're going to use this little discovery that connects the idea of opposites into our rules for multiplication and division to see why they work. In section A, we're starting with negative times a positive. And they give you a little bit of an example here. For this first problem, we see that it's negative 2 times 3. And they're letting us know that this negative can also be interpreted as the word opposite. They mean the same thing. So what they're saying is when you're doing negative 2 times 3, it's the same thing as just doing 2 times 3 and then taking the opposite. So 2 times 3 is 6. The opposite of 6 is negative 6. You're going to fill out the rest of this chart the same way. You'll notice that they use different representations for multiplication, but they all mean the same thing. The dot, the parentheses, all of that means times, and it's kind of like a more grown-up way instead of using the X. So all of these are a multiplication problem, and you're filling it out the exact same way that I just did the first line. You don't even need all of my notes. You just need the interpretation and then the answer. When you finish the table, you're also going to fill out the conclusion below. Go ahead and pause the video and then unpause it when you're ready to check your answers. All right, hopefully you have that whole table filled out. So the second one would be the opposite of 8 times 1. 8 times 1 is 8. Opposite of that is negative 8. Next one is opposite of 12 times 2. 12 times 2 is 24. Opposite is negative 24. Last one is opposite of 6 times 8. 6 times 8 is 48. Opposite of that is negative 48. And this gives us the conclusion that if you're multiplying a negative number times a positive number, the answer will always be negative. All right, let's look at section B. Now this is the exact same thing, except the second number is the negative one this time. But let's look at the interpretation example. It says 5 times negative 4, and we're interpreting that to be the opposite of 5 times 4. So this actually is exactly the same interpretation as section A. It doesn't matter which one is negative. If the 5 was negative, the interpretation would be the same. If the 4 is negative, the interpretation would be the same. So you still convert this little negative into in front of the 4 into the word opposite. So you take the numbers, multiply them, and then take the opposite. It doesn't matter which number was the negative one. So 5 times 4 is 20. Take the opposite, negative 20. Go ahead and fill out this whole chart plus the conclusion at the bottom. Pause the video and come back when you're ready to check. All right, hopefully you're ready to check. We have the opposite of 9 times 2. 9 times 2 is 18. Take the opposite, negative 18. Opposite of 10 times 1. Opposite of 10 times 1 is 10. Opposite of that is negative 10. Lastly, opposite of 8 times 7. 8 times 7 is 56. Take the opposite. It is negative 56. And the conclusion is that a positive number times a negative number will always be negative. So what we've learned so far is that you can multiply a negative times a positive or a positive times a negative, and the answer will be negative. It doesn't matter which one is bigger, like the addition-subtraction rules. It doesn't matter which one comes first. It's just automatically negative if you have one of each sign. All right, let's do the bottom part. So negative times negative. You'll see that now we have 2 negative signs given to us. And that means in our interpretation, we're writing the word opposite twice. Negative and opposite mean the same thing. So instead of thinking about it as negative 4 times negative 10, when we're trying to figure out why the rule works the way it does, we could think of it as 4 times 10, then take the opposite of the opposite. So 4 times 10 is 40. The opposite of that is negative 40. The opposite of that is positive 40. Now, this isn't how you would think of it for the rest of your life. You would just learn that the answer to this is 40 without thinking about the opposites. We're only doing it now because we're determining why the rules work the way they do. Go ahead and pause the video and see if you could fill out the rest of the page, including section D, and then unpause when you're ready to go over it. All right, hopefully you're all done. So the next one would be opposite of the opposite of 5 times 7. So that's 35 for 5 times 7. Opposite makes it negative 35. Opposite again brings us back to positive 35. Next, opposite of 2 times 15. So 30, then take the opposite twice. It's still positive 30. Lastly, opposite of 9 times 6. 9 times 6 is 54. The opposite of the opposite will bring it back to positive. So I'm noticing that all of these answers are positive. So a negative times a negative will be positive in its answer. And that's because you're taking the opposite twice. You can kind of think about how these all have pairs of opposites, 2 opposites beforehand. And when you have 2 opposites, they just cancel each other out and become a positive. All right. And then section D, positive times positive. You guys have been learning this since what, first grade? You know that positive times positive is going to have a positive final answer. So what we're going to do on the next page is summarize everything we just learned. We learned 2 different charts about problems with different signs, one positive and one negative. Then we learned 2 different, not charts for the second one, but 2 different examples of same sign problems. So sections A and B taught us about different sign problems, so one positive and one negative, and we learned that no matter what, the answer is going to be negative for those. Then section C and D taught us about same sign problem. So this would be 2 positives or 2 negatives. And we learned that those answers will always be positive. So different signs, negative answer. Same sign, positive answer. It doesn't matter which one's bigger. We're going to take that information and summarize it on the next page. All right, so summary. We learned that if we're starting with same signs, positive times positive is a positive answer. Negative times negative is a positive answer. Different signs. Positive times negative is a negative answer. Negative times positive is a negative answer. So overall, we could say that same signs is going to be a positive answer no matter what. Different signs is going to be a negative answer no matter what. The rule that people always get confused with is this one, negative times negative, because I want to show you the difference. What if I do negative 5 plus negative 3 and compare that to negative 5 times negative 3? For negative 5 plus negative 3, we know that we have to add their absolute values and keep the sign the same. That answer is negative 8. But when I multiply, 5 times 3 is 15. Take the opposite of the opposite, positive 15. That's a positive answer. So people get confused there. When you're adding or subtracting with 2 negatives, it's a negative answer. When you're multiplying or you're going to find out dividing 2 negatives, it's a positive answer. And that's something that confuses people. So try to keep that straight in your heads. Adding and subtracting have different rules. All right, go ahead and do section F, practice, and then pause the video and then unpause it when you're all done. All right, let's check those answers. Number 1, 5 times 2 is 10, and those are different signs, so it's a negative answer. Problem 2, those are same sign, so it's going to be a positive answer. Problem 3, those are same sign, so it's going to be a positive answer. Problem 4, those are different signs, it's going to be a negative answer. Problem 5, sorry I sound so repetitive, is same sign, positive answer. Problem 6, same sign, positive. Problem 7, different signs, negative. Problem 8, same sign, positive. All right, let me show you how section G is asking you to do the work. This is a long string of numbers, and I am not asking you to actually calculate it. The first column is asking us to find how many opposites or negatives you see in the problem. All right, so let me look. 1, 2, 3. Won't highlight, hold on. There we go, 3. So that's what I'm gonna put here. Now I'm wondering what the sign of the answer is. So if I take the opposite of the opposite of the opposite, there's 3 negatives in my problem. We already learned this the day that we learned about opposites. We learned that 2 of those negatives will pair up and become a positive, but because there's an odd number, there's 1 left over, the final answer will be negative. See if you could fill out the rest of this page, pause, and then unpause when you're ready to check the answers. All right, hopefully you are ready to check. So in the second one, there are 4 opposites or negatives. So this is how it would look. There's 4 of them. Pair, pair, those both become positive, nothing left over, positive final answer. The next one is 6, and for the same reason, it's positive. The last one is 2, and for the same reason, it's positive. So in the conclusion, if you have an even number of negatives being multiplied, the answer will always be positive. If you have an odd number of negatives being multiplied, the answer will always be negative because of what we just showed. There will always be 1 left over that doesn't have a pair that keeps the problem negative. So that is multiplication. Now we're going to apply those rules to division on the last page. And instead of making you fill out 4 different charts, I've combined all of the different examples into one chart for you. So let's look at section A. Starting with negative divided by positive. So they give us the problem negative 20 divided by 4. I see 1 negative there. So I'm going to translate that into the word opposite. It works the same way as multiplication. 20 divided by 4 is 5. Take the opposite, negative 5. All right. So actually, I want to do the next one before I have you start. So the next one doesn't have any opposites at all. It's positive divided by positive. So I'm just writing 20 divided by 4. There's no opposites or negatives. So 20 divided by 4 is 5. In a moment, I'm going to have you pause and fill out the rest of A and B. And then unpause when you're ready to check it over. All right, hopefully you are ready to check it over. In A, I have 20 divided by negative 4. This is a positive divided by a negative. I'm going to pull that opposite out in front. Opposite of 20 divided by 4. 5, and then take the opposite is negative 5. So I want you to notice how the first example and the third example have the exact same interpretation. It doesn't matter if the negative is on the 20 or if it's on the 4. The reasoning behind the answer is the same thing. 20 divided by 4, then take the opposite. Now let's do the last one. This is going to be the opposite of 20 divided by 4. The last time you're going to have to write opposite. You're done writing that now. 20 divided by 4 is 5. Opposite gets me to negative 5. Opposite again, back to positive 5. So the rules are exactly the same. For multiplication and for division, if you have same sign, it's going to be positive. If you have different sign, it's going to be negative. I've already highlighted the 2 examples that had different signs. I'm going to finish highlighting those. The ones without the highlight are the same sign examples, positive divided by positive and negative divided by negative. So both of those ended up with positive answers. So same sign equals positive, just like multiplication. I knew it wasn't going to like that eraser. Okay, now the highlighted examples are my different sign examples. Since there will always be an odd number of negatives if they have different signs, it is therefore a negative answer either way. And different signs, the rule is it'll always be negative. So the rules for multiplication and division are exactly the same, much less complicated than the addition and subtraction rules as well. If they're same sign, it's positive. If they're different signs, it's negative. And that's it. I am going to show you a special case, and that has to do with undefined answers. For this, the explanation is a little tricky, so try to follow what I'm doing step by step. Let's start with the first one, 0 divided by 4. In order to understand this problem, we're going to look at the reasoning example. 4 times what equals 0? Whatever we can substitute in for that question mark is going to be the answer to our division problem. Well, 4 times 0 is 0. If 4 times 0 is 0, then 0 divided by 4 must be 0. The answer to that is therefore 0. But what happens if I put the 0 on the bottom? Okay, so now let's look at our reasoning. 4 divided by 0. We want to find out what times 0 equals 4. Pause and try to answer that. Okay, hopefully you've tried to answer that. There is nothing that you could put in that question mark to make it true. 0 times anything is 0. It can't be 4. It can't be any other number. So because there's no number in existence that answers that question, we say that the answer to that is undefined. There is no number defined that answers that question. So if 0 is on the bottom, no go, not good, undefined. This is the same thing as 4 divided by 0, with the 0 being the second number. And the one above is the same as 0 divided by 4, with the 0 being the first number. All right, the next one is 0 divided by 0. It's the same thing as this. So to answer this, we're going to look at our interpretation, our reasoning. 0 times what equals 0? Pause for a second and try to answer that. Did you come up with a lot of answers? 0 times 1 equals 0, 0 times 1/3 equals 0, 0 times negative 100 equals 0, anything. But that's not good either. In math, there's supposed to be one answer to any division question, not whatever answer you feel like. So because the question mark could be anything, we also call this one undefined. There's not a defined answer to this. Anything could be an answer, so it doesn't work in math. So that's another example where we had the 0 second. Even having the 0 first and second doesn't change it. If the 0 is second, or if the 0 is on the bottom, that means the same thing. The answer is undefined. And I'm going to jump down to the conclusion. The way I like to remember this is underline is undefined, meaning if 0 is the number under the fraction bar, if 0 is the second number, the answer will be undefined. Another way I've seen people remember this is with okay and no. So if you write 0 on the top and then any number you want on the bottom, it's okay. The answer is 0. But if you have any number you want on the top and 0 on the bottom, that answer is no, it cannot happen. So the answer is undefined. A calculator is also going to show you very similar results to this. So let me bring out my calculator really quick. So 0 divided by whatever number I want, let's say 9, it gives me an answer of 0. That's good. But 9 divided by 0, switching them, I get an error because it's undefined. Some calculators actually say undefined and some say error, and they have like different messages depending on what calculator you're using. The fancier ones will actually say the word undefined. All right, try to do this last section. Excuse me, you're just copying what I did in the first section. And then when you're ready to check, unpause and look at the answers. All right, so hopefully you're ready to check. So for the 0 divided by 7, that's the same thing as 0 divided by 7 this way. 0's on the top. That's all good. That answer is going to be 0. And your reasoning is because 7 times 0 equals 0. That's all good. Second one, the 0 is the second number. No go. 0 times nothing will equal 7. So the answer is undefined. That's another way to abbreviate it, and some calculators will show it abbreviated with UND. Last one, 0 divided by 0. 0 times anything is 0. So that's no good. It's also undefined. And another symbol for undefined is like that little 0 with the cross through it. That means there's no such answer. It is undefined. This was a pretty long video. I really appreciate your attention during this. Thank you so much for watching.